All right, so hopefully everything we've learned in the last lesson made sense, and you're ready to put your knowledge to the test by completing the first coding challenge today. And what you're going to be building is a grading program. So if you take a look at the day 9.1 grading program Replit coding exercise, you'll see that to begin, I've already created a dictionary with a bunch of student names and their test scores. Now, without changing any of the code above here or below here, I want you to write a program that will be able to convert these scores into a grade. So the grading criteria is over here in the instructions. So if the student scores above 91, then they'll get the grade outstanding. If they score above 81, they get exceeds expectations and then acceptable. And then finally, everybody scoring 70 or lower gets the fail grade. Essentially, what you're going to be doing is creating an empty dictionary from scratch, which is going to be called student grades. And you're going to write some code so that each of the students are represented inside this new dictionary. And instead of having scores as the values in that dictionary, you're going to have the grades that correspond to the scores that they got. So have a read through the instructions and the hints if you need some help. But once you're ready, go ahead and pause the video and give this a go. All right, so to begin, let's first tackle this to-do one. Let's create a new empty dictionary called student grades. And the student grades has to be spelled exactly the same as you see here, because otherwise this print statement will not work. Student grades is going to be an empty dictionary, which, if you remember from the last lesson, we said it looks like this with two curly braces and nothing inside. Now let's move on to do number 2. So we're going to write some code below so that we actually add the grades to this student grades dictionary. And we, of course, can get those grades by looking at each of the students' scores. How can we do this? Well, we're probably going to need a for loop because there's lots of items in this dictionary. Let's go ahead and loop through this student scores dictionary. And I'm going to call each of the items the student, because remember, when we have a for loop looping through a dictionary, like we are doing here, each of the items that gets picked out is actually the key rather than the whole item. So again, we talked about this in the last lesson, but hopefully this should really make it clear. But even if you didn't know, you could always, of course, just print it, right? So if we go ahead and use the for loop and print it, you can see we get all of the keys from this dictionary when we're looping through it. So for each of the students, we want to get hold of their score. We can calculate the score by getting hold of the value using this key from this dictionary. And to do that, if you remember, is tapping into the dictionary, adding a set of square brackets, and then giving it the key. So in this case, it's going to be each of the student names. And once we've got hold of the score, well, then we can use our if statement to check, well, if the score is greater than 90, so anything above 90, then that means they're going to end up with outstanding. Now, this is the part where we add a new entry to this student grades dictionary. So let's tap into the dictionary, use a set of square brackets again to give it a key. And the key, of course, should still be the student name, which comes from here, which is going to be the same as this. Then we can add a equal sign and followed by the value, which is going to be outstanding. So now we can repeat this process for the rest of these grades. Everybody who scored above 80 but not above 90, so remember that this if statement, once triggered, will skip all of the rest of the elif statements. And then if they scored above 70, they would get acceptable. And finally, for everybody else, which means they scored lower than 70, then they're going to end up with a fail grade. Now, it's really important that if you want the tests to pass, that each of these strings has to match what you see over here exactly. Now that we've done all of this hard work manipulating our dictionary, it's time to actually go ahead and run our code and see what we get. So now our code has converted each of these scores to the corresponding grade. Harry exceeds expectations because his score is between 81 and 90. Ron gets acceptable because it's between 70 and 80, and so on and so forth. Now, did you manage to get it right? Or did you have any problems working with dictionaries? Now, if you go beyond this lesson, I'm going to assume that you're comfortable with editing dictionaries, adding to it, creating new ones. So if you're not yet fully there, then I recommend just going back to the last lesson and just reviewing it once more. Once you've done that, head over to the next lesson and we're going to talk more about nesting in dictionaries and lists. For all of that and more, I'll see you there. Now that we've seen lists as well as dictionaries, I want to talk about a concept that you often see in both of these collection types, and that's something called nesting. Now, if we imagine a list or a dictionary being something like a folder where lots of things can be stored inside it, then nesting lists and dictionaries is just a matter of putting one inside the other. For example, here's a dictionary that is very simple. It's only got one key value pair. Now, we know that we can add multiple key value pairs into the same dictionary by just adding a bunch of commas to separate them. Now, what if instead of having a simple value like a string or a number, I could also put a list as a value as well? Similarly, I could also use a dictionary as a value. In this case, we've got a list as the value for key, this first one, and we've got a dictionary as the value for key 2. Notice how this is a list and a dictionary nested inside another dictionary. The structure gets a little bit more complex, but it gives us more flexibility when we're trying to store more complex pieces of data. Coming back to our code, let's go ahead and create some sample dictionaries to see what this actually looks like in real life. For example, this could be a dictionary that contains the country as the key and the city, that is the capital, as the value. So for France, that's Paris. For Germany, that's Berlin. This is a very simple dictionary that you've seen already. Now, if I wanted to nest a list in a dictionary, then I would be able to represent even more complex data. For example, if I had a travel log where I was going to collect a dictionary of all the cities I had been for each of the countries I've traveled to. So, for example, if I had traveled to France and I wanted to say that I've been to multiple cities, I can't simply just say Paris and then Lille, Dijon. That doesn't really work because each key can only have one value. The only way that we can make these 3 pieces of data one value is by turning it into a list, like so. So now in our travel log dictionary, as represented by the curly braces, we have one key value pair, and it just so happens that the value in this case is a list. And of course, you can go on and add as many entries as you would like, and still preserving this kind of structure of key being a string and the value being a list. Now, this idea of nesting isn't limited to dictionaries, by the way. You could also just nest a list in a list. So you could have a list which is A and then B, and then the third item just happens to be another list which has C and D. This is perfectly valid Python code, but it's not quite as useful as nesting a list in a dictionary or a dictionary in a dictionary because of the way that data is structured. Now, what if you wanted to nest a dictionary in a dictionary? Let's say that we wanted to expand our travel log. And instead of just storing the cities that I've visited in each country, what if I wanted to also keep track of how many visits I've made to that country? Or what if I wanted to actually label what this piece of data is? Because at the moment, it's kind of like, here's a bunch of cities that's associated with a country, but it doesn't really describe this list. And I'd like to give this to you as a challenge. Have a go at changing the France entry so that it contains another dictionary. For the nested dictionary, use the key cities_visited, and for the value, you can keep the list of Paris, Lille, and Dijon. Pause the video now and see if you can get that to work. Alright, so here's the solution. By nesting a dictionary, we can label the Paris, Lille, and Dijon list as cities visited. All I need to do is create the string cities visited and add a colon after it. But there's one more step. We have to add a pair of curly braces so that France is associated with a single value, namely our nested dictionary. Now we have a dictionary of the travel log, all the countries I've been to, and each country has a value that is a dictionary in itself. And it can store multiple pieces of data, including the cities I've visited in that country, as well as things such as the total number of visits, which in this case would have a string as the key and a number as the value. Now have a go at creating your own travel log or modifying the second part of the travel log so that you also have a dictionary nested in a dictionary. And you're able to represent something like this: the number of cities you visited in a list and another additional piece of data if you wanted to. And hopefully you would have done something similar to this. And so now our data structure is such that we've got a list nested inside a dictionary, which is in itself nested in another dictionary. Now that we've seen nesting lists inside dictionaries, dictionaries inside dictionaries, the last thing I want to show you is nesting a dictionary inside a list. So we could basically have multiple dictionaries inside a single list. So remember that lists are ordered and they're accessed by the positions inside the list. So this dictionary would be the item at index 0, this one at index 1, and so on and so forth. Whereas inside a dictionary, the items are accessed by their keys, like this France or Germany. Now, I want to do the last type, which is nesting a dictionary in a list. And I'm going to be working with the same travel log that we had previously, but I want to change it so that instead of having this being one giant dictionary with key value pairs, I want to change it so that each of these entries are a dictionary in itself. Instead of having France be the key of this dictionary here, I want to turn it into its own key value pair. Going inside this dictionary, I'm going to create a new key, which is called country, and then put France as the value for that key. So now I have an entire dictionary that has 3 pieces of data: the country visited, the cities visited, and the total number of visits. Let's do the same for Germany as well. So now you can see we've got 2 dictionaries. And instead of holding these 2 dictionaries inside a dictionary, I'm going to change it so that it's now a list. I'm going to turn these curly braces into square brackets, and this way we can add as many of these dictionaries inside the list and iterate through them if we need to. When we've been creating dictionaries that only have 1 or 2 key value pairs, we've kind of just kept it all on one line. But once you've got more and more key value pairs in the dictionary, it's usually a good idea to go ahead and separate out each of the entries, like what I'm doing here. Now it's a little bit easier to see that we have a list which contains 2 items, and each item is a dictionary. Each dictionary has 3 key value pairs, and they all contain different types of data. The first one has a value, which is a string. The second one holds a list, and the third one holds a number. The data types inside a dictionary can be completely mixed up if you want it to, but what can't change is you still need a key and a value separated by a colon. Now, the only downside to this is you want to make sure that you're actually aware that later on when you try to pull out the number of visits, it's actually a number that you're working with rather than a string, or when you're trying to get hold of the cities visited, it's a list rather than a dictionary, for example. So now that we've seen various different types of nesting, it's time for you to actually really understand this and get to grips with this concept by completing a challenge yourself. In the next lesson, I've got a coding challenge for you based on this travel log, and you'll need to use what you've learned so far to be able to complete it. So for all of that and more, I'll see you on the next lesson. Now if you head over to Replit, click on Day 9.2 Dictionary in List, this coding exercise should appear. And you'll see that we actually have the same list that we created at the end of last lesson. This is a list called Travelog, and it logs the countries that we've been to, how many times we visited it, and the cities that we visited while we were there. This is a list of dictionaries which contain a list of cities. There's some heavy nesting going on here. Now, your job is to make sure that this line of code on line 20 and 21 actually work. In order to make it work, you're going to have to write a program. So it's going to be a function that's going to go somewhere in here, and you're going to get it to be able to add new countries, the name, the number of visits, and the cities that you've been to, so that it gets populated in the travel log. And when we print travel log at the end, it should show us all three of these entries. So remember, the goal is not to modify this directly. In fact, I don't want you to touch this part at all. Instead, it should be your function that's going to somehow go through this travel log and add these new pieces of data. Have a think about how you're going to achieve this, and then pause the video and give it a go. All right, so because we've already defined the name of the function here, in order for our code to actually work and for the tests to go through, we also have to create the function using exactly the same name. So it's called add new country. And then the inputs that it's going to take are the country visited, the times visited, and finally the cities visited. So now that we've created our new function, the next job is to figure out, well, how do we add these pieces of data that's going to be passed in to these parameters and get that into this travel log? So the first thing you need to notice is each of the entries inside the travel log is a dictionary. In order to add to that list, we should probably start off by creating a new dictionary that has all of these pieces of data in it. For example, we could create a new dictionary called new country, which is an empty dictionary, and then we can add each of these pieces of data to the dictionary. So we could say new country, square brackets, and then we give the key that we want to add. So in this case, it would be the key country as a string. And the data or the value that's going to go in that is going to be whatever gets passed into country visited. So now all we have to do is repeat the process for the other keys in the dictionary. So visits is the next one, and that's going to be set equal to the times visited. And finally, we're also going to populate the final key, which is cities. And that is going to be equal to the cities visited. Now, at this point, if you were to print out new country, you should see a dictionary with 3 key value pairs. And the keys will always be the same, but the values will depend on which arguments were passed in when this function was called. So once we have that new country, then we can actually take our travel log, and remember that the travel log is actually at its base a list. So instead of adding to it like we have been doing when we're using a dictionary, in order to add to lists, if you remember, you should probably use the function append. And inside here, we can add a new item to our list. And that new item is, of course, going to be this dictionary called new country. So now if we go ahead and click run, then you can see when travelog gets printed on now line 27, it's now got 3 entries. The first entry is the dictionary for France, the second is the dictionary for Germany, and the last one is the dictionary for Russia. We have now a list with 3 items, each being a dictionary, each with a nested list inside as well. So if you wanted to, you now have a way of keeping track of all the places you've visited. And later on, as we start building out more complex apps and web applications, then you can easily see how logic like this might be really useful if we were building a real-life website for tracking our travels. Have a play around with nesting dictionaries and lists. And once you're happy that you've understood everything that's going on, then head over to the next lesson and we're going to start tackling our final project. All right, so now that you've learned all about dictionaries, we're going to put all of that knowledge to test and to use by building a blind auction program. So here's the program. When you first run it, it's just going to show you the logo art and maybe a line that tells you what program you're in. And then it's going to ask you for your name. So let's say we have 3 bidders, right? So first go, I go to the computer, I type in my name, I type in my bid, and I hit enter. It asks me if there are any other bidders. I look around the room, I see 2 other colleagues, so I type yes. And now it clears the entire screen so that other people can't see what my bid was. So now I leave the computer and my colleague comes over. They type in their name and also their bid. And again, they look around the room and they see there's 1 other person who wants to bid. So they hit yes. Again, it clears their bid. And finally, the last person makes their bid. At this point, everybody has bid, so she's going to type no. And it's at this moment when our program is going to work out who has made the highest bid and print out who the winner is and what their bid was. This way, instead of competing with each other on bids, we actually all just give the highest price we're willing to pay, and this is known as quite an efficient way of making a bid. And you see that a lot in, say, the construction industry and government, etc. The important thing in this program is you're going to start out using the blind auction start replit. And the first thing you'll notice is that I've already imported this function called clear from the replit module. And you can basically call this function clear whenever you want to clear the output, just as you saw here. Whenever we typed yes after being asked if there are any other bidders, that just calls the clear and then it gets rid of everything that's in the console. In addition, we've also got the starting art of the gavel logo, which you're going to put into the program. And the most important thing of all is that I want you to create a dictionary so that each person's name will be the key and their bid will be the value. And this dictionary is going to contain many of these key value pairs. And at the very end of the program, when everybody's done with bidding, then we're going to loop through that dictionary and figure out who has made the highest bid. If you want, this is a good time to analyze this completed project and see if you can create your own flowchart using something like Draw.io that I've shown you before, or just take a piece of paper and a pen and draw out your flowchart. Now, if you want a hint, then you can head over to the course resources and you'll get taken to the flowchart that I've created for this program. So spoiler alert, I'm about to show you that flowchart. So if you don't want to see it and you want to create your own because it's a relatively simple program, then pause the video now and complete the challenge by yourself. Now, for everybody else who's still here, I want to show you this is a flowchart I've created to represent this program. So we start at the beginning, we first show the logo from that file art.py, and then we ask for a name input, we ask for their price. Now we're going to add the name and the bid into a dictionary with the name as the key and the bid as the value. Now, once we're done with that, then we get to ask the user for another input and see if there are any other users who want to bid. So if they answer yes, then we're going to clear the screen and we're going to go back to here, ask for another name, another price, and so on and so forth. But if they say no, everybody's done with bidding, then we're going to call some sort of function that we have, which is going to loop through our dictionary that was created here and find the person who had the highest bid value and then declare them as the winner and print out their bid. So it's a relatively simple program, at least compared to other things that you've built so far. So this is the time to pause the video and give it a go. I'll see you on the next lesson where we'll go through the solution together.